Hi, this is Ben McCone with Technically Speaking at Source Allies. Today, we're going to be doing something a little bit different. Today, we are going to be solving Day 3 of Advent Code 2024 live on Technically Speaking. Source Allies is a sponsor this year, and so we thought we would tie in Technically Speaking and share a few of our teammates' solutions along the way. Let's go ahead and dive in and look at the problem for today. So we can see that Day 3 is all about the elves having a corrupted input file that has, really it's corrupted memory. They have multiplication throughout, and we need to, for part 1, extract those multiplications. We need to perform the multiplication, and we need to add the results together. So I will go ahead and copy this solution, and we will set up our test case to expect the answer 161. For today, I will be using the Ruby programming language. I personally really like to use Ruby for Advent of Code. I think there are a lot of helper methods that really help out with the readability and the expressiveness that lends itself very well to Advent of Code. In here, I have some boilerplate that I like to set up for every day of Advent of Code. We have 2 tests. The first one is test part 1, test part 2. We have assertions, so we said that this is 161 on part 1, and we also have some helper functions to automatically download my actual input from Advent of Code. On the right, I have my tests running on every file change. So now that that is in place, let's go ahead and go over to the actual code where we will begin implementing part 1. In that input, I know that we need to pull out anything that looks like mul, number, comma, number, with a closing parenthesis. In Ruby, what I will do is I believe I can use scan here. Multiplications equals input.scan. This is a scan allows us to provide a regular expression, and it will return us an array of everything that comes out. So what that looks like is MUL. We will escape that opening parenthesis and that closing parenthesis. We will look for any numbers. And for good measure, let's just return multiplications so that we can see what comes out. We see that what we get is exactly what we expected. MUL 2, 4, MUL 5, 5, 11, 8, and 8, 5. That is a really good first step. Now we need to work on getting those numbers out. So for this, I'm going to create a product, and that is multiplications.map. And we are going to take in our string. And for each string, we're again going to use scan. So we will do a, b equals string.scan for all of our numbers. And because we know that there are 2 entries with each of these, we can automatically destructure those into A and B. And finally, we just do A.2i times B.2i. That will return us the list of products. And finally, we can do products.sum. I'll go ahead and save that. And this says that our part 1's answer is a very long number. Let's switch back to Chrome and paste in our answer. Perfect. Part 1 complete. Let's go ahead and look at part 2. We see, as we scan through the corrupted memory, we notice that there are conditional statements that are also intact. So there are 2 new instructions that we need to handle. We need to handle do, enables future multiplication instructions, and don't, which disables future multiplication instructions. Only the most recent do or don't instruction applies. At the beginning of the program, instructions are enabled. So let's go ahead and start on part 2. In that example, thankfully do they use the same input? They do not. So we will go into our test. We will quickly change our part 2 test input to our multiplication result, and we will assert that that equals 48. From here, we can save. We see part 2 is expecting 48. We're actually getting 0. That is to be expected. And let's go ahead and do something very similar, but this time let's call it instructions. So we're going to look for multiplication. We're going to look for do, again with those escaped, or we're going to look for don't with those parentheses escaped. So now, just as we did in part 1, let's return instructions so we can see what this looks like. So we're looking at multiplication, don't, multiplication, multiplication, do, multiplication. So from here, we can, let's first start by updating instructions to remove anything. Let's not remove things as a pre-processing step. Let's go ahead and just read through the list a little bit differently than we did previously. We can start with enabled equals true, and then for instruction in instructions, my Python came out there a little bit. Do and print instruction. Let's make sure that this syntax is correct. Expected. That is not the correct syntax, so we will just do instructions.each do instruction, and this should work just fine. What is going on? One moment. I think this might just be swallowing expectations. Or print statements, rather. Let's go ahead and if instruction is do, then that is enabled equals true. If instruction, and we will also say next to continue on to the next loop. If instruction is don't, then enabled equals false, and we want to go next. And finally, we want to do something very similar. Products equal, we'll just create an empty array outside because not every instruction is now a multiplication. Now we will say, we will take this same exact piece up from part 1. We will do that math to I, and we need to do one more piece. We need to say if we are not enabled, then we need to also continue. We don't want to do multiplication if the computer is turned off. And finally, products, we will append the multiplication result. And finally, products.sum. And we will see we will just change this to unless enabled. That should work just fine. What are we doing wrong? It's time to do some debugging. Unmatched keyword. Should this be then? All right, undefined local variable string, that is right because that is now instruction. And that is a part 2. Let's see if we are correct. And it was. So today we ran into a couple of syntax errors, just some I'm a little bit rusty with Ruby. We do then instead of do, but let's do a quick review of these solutions. From the top, part 1, we pull out all multiplication results. We don't care about the do's and the don'ts. For every product, we scan that string for the numbers. There could be more than one, so we did add the plus to grab all digits. We converted those resulting strings to integers. We multiplied them together to get our products array. And then finally, we returned the sum of those products. For part 2, we did something very similar. We looked for all of the multiplication function calls. We also looked for any calls to the do function or to the don't function. We keep track of the enabled flag. And for each instruction, if our instruction is do, then we enable processing of multiplication, continuing to the next loop, because that is all to do on this run of the loop. We then check for don't. If we receive that, we disable multiplication processing. If we are not enabled once we get down past those two checks, we continue because we have disabled multiplication processing. And then finally, we do what we did in part 1. We grab the numbers from the multiplication call, and we multiply them together, adding them to our products array, and finally put that in through the sum function, returning our results. Thank you for joining me on this quick video through Advent of Code Day 3. This has been Ben McCone with Technically Speaking at Source Allies. Do you have a topic you'd like to see covered? Comment it down below. Check out sourceallies.com to learn more about us. Thank you for watching, and we'll see you next time.